Assalamualaikum warahmatullahi wabarakatuh. We have now come to chapter 4.6, Integrate Trigonometric Function. So please take note that this chapter is a bit tricky. So let's go through the cases one by one so that you are clear on what you should do. So basically what we need to do is we need to alter first the equation using trigonometric identities, and after that we need to use substitution according to the cases. So even though this is a bit tricky, but don't worry, we will go through all the cases one by one. So altogether we have 5 cases, and we will go through one by one according to each case. The first one is the question involving product of cosine and sine. So whenever you see the combination of integration cosine and sine, you need to remember to follow either case 1 or case 2. Now let's focus on case 1. If you have integrate of cos to a certain power and sine to a certain power of dx, so the first case is referring to either one of the function have odd power. Okay, so either your cos is odd power or your sine is in odd power. So if you meet this kind of question, what you should do, the first step is you need to split the odd factor. What's the meaning of split? If this is power of 3, so you need to split the odd factor. One should be power of 2, another one should be power of 1. Okay, that's the meaning of splitting the odd factor. So after we have split the odd factor, we need to use the trigonometric identities. Sine squared plus cos squared is equal to 1. And then we'll proceed to solve the question. Now let's focus on example 1. So this is case number 1, either one is odd, because the question is sine to the power of 3 and you have cos x to the power of 2 dx. So one of them, your sine factor here is odd. So what should you do in this case? We need to split the odd factor and use the trigonometric identity. So let's do this. This is your odd factor, so let's split this. So this is sine to the power of 2x and sine x, and just rewrite back cos squared x dx. Then let's take the square here and let's open up using the trigonometric identities. So the trigonometric identities for sine squared is 1 minus cos squared, and let's rewrite back your cos squared, and let's rewrite back your sine x dx. So for the majority of trigo here, which is cos, we need to let u as our cos x. So since u is equal to cos x, du over dx is just minus sine x, and dx is equal to, just cross multiply, du over negative sine x. This is very important because we will cancel out the remaining sine x with the 1 in the denominator. So from here, let us change everything using u substitution. So this is 1 minus u squared, this is u squared, sine x, just rewrite it back, and your dx is equal to du over negative sine x. Just rewrite this here, and let's solve this. Sine and sine you can cancel out, and the negative here is a constant, just take it outside. And for the rest of this, let us expand. So you have integrate u squared minus u to the power of 4 du. So now let's focus to integrate this. This is very simple. Just add 1 to the power, divide by new power. So put negative outside and a big bracket. This is u to the power of 3 over 3 minus, this is u to the power of 5 over 5. Don't forget to write plus c. And finally, after you have finished integrate, let us back substitute. Your u should be written as cos x again. So the answer is negative cos x cubed over 3 minus and minus is plus cos x to the power of 5 over 5 plus c. So this is your final answer. So this will be very simple if you are able to screen first which case are we right now, which is we are case 1, which either one of cos and sine here is odd.